Welcome back to the Deep Dive. Today, we're getting into Tesla's full self-driving, or FSD. And specifically, it's a very unique end-to-end vision-first strategy.
It's definitely a different path than many others are taking.
Right. So our goal here is really just to unpack the facts. What can it do? What's the tech behind it? What are its strengths, its current limits? Just a clear picture for understanding where it fits.
Okay. So when we talk FSD, we mean Tesla's, advanced driver assistance software. It's designed to handle highways and city streets with, let's say, minimal driver input needed.
Building on autopilot, right?
Exactly. It adds things like navigate on autopilot for highways, automatic lane changes, handling traffic lights and stop signs.
And the big one, city street driving, that came with FSD beta.
Yes, that was a major step.
But the really interesting turn, especially now in 2024, 2025, is this FSD version 12 and onwards. It's become this AI-driven end-to-end system. What does end-to-end actually mean in this context?
Yeah, that's really the core of it.
Yeah.
So traditional systems, they usually break driving into steps, right? You have perception, then prediction, planning, control. Each part often has lots of explicit handwritten rules.
Like C++ code deciding things.
Precisely. Tesla's approach, this end-to-end neural net pipeline, is different. The input is just the raw video from the 8 cameras.
The cameras, okay.
And the output, direct driving commands, steering, accelerating, braking. It's almost like showing an AI videos and having it output how to drive directly.
So all that logic for planning and control, it's now inside the neural network itself, especially from V12.
That's right. They essentially removed, I think the number was over 300,000 lines of that explicit C++ code.
Wow.
Replaced by a single AI model trained on, massive amounts of driving data.
That's a fundamental change in architecture then.
Absolutely. And that brings us to the key parts of their stack. First, it's pure vision, only cameras.
No LiDAR, no radar.
Correct. They rely heavily on things like vision transformers, neural rendering, basically advanced AI to build a 3D understanding, a bird's eye view just from the cameras.
And then the planning is also neural.
Yes, neural planning. The driving policy, how the car decides what to do, is itself a neural network. It's trained end-to-end by imitating good human drivers using millions of video clips.
Okay. And I've heard about occupancy networks.
Right, that's another piece. Instead of trapping every single object explicitly, it models the 3D space around the car as simply occupied or free directly from the video input.
Simpler in a way.
Potentially, yeah.
Yeah.
And then you have things like hydronets. These are kind of like multitasking networks. They share the basic perception, but then output different things simultaneously, lanes, objects, even figuring out if a gap is drivable.
And underpinning all this is the data and the training infrastructure.
Exactly. Massive data sets from their fleet, millions of cars feeding data back, and their own custom supercomputer, Dojo, built just for this training.
So why? Why go this end-to-end route? It seems much harder in some ways.
Well, the thinking is it gets closer to human-like driving. We sort of just see and drive, right? We don't consciously calculate every variable using rules.
Yeah.
This approach might generalize better, learn subtle things that are hard to code, and maybe counterintuitively, it can lead to a simpler stack. Fewer hand-coded rules means improvements often come from more data, rather than rewriting complex logic.
So less explicit programming, more learning from experience, basically.
That's the idea, shifting from programming every scenario to letting the AI learn the nuances.
Okay, so how's it actually performing? What are the current strengths and weaknesses?
Strengths are definitely the rapid scaling. That fleet data is a huge advantage. They hit, over 100 million miles logged on FSD beta by 2025.
That's a lot of data.
It is. And it generally performs well in many U.S. city and highway situations. Plus, it works on relatively standard hardware, just the cameras and the onboard computer.
But the limitations?
Well, the big one often cited is explainability. Neural nets can be black boxes, hard to know exactly why it made a certain decision.
Which is tricky for safety and regulation.
Exactly. It can also struggle with really unusual edge cases, complex construction zones, maybe rare road signs it hasn't seen much. And, crucially, it's still level 2 assistance. It requires the driver to be fully attentive and responsible at all times. It is not fully autonomous.
Right, not level 5. Constant supervision needed. And the updates show this progression, right? V12 in 2024 was the big end-to-end vision-only leap.
Yes, that was the major architectural shift becoming operational. And now V12.3 and onwards are rolling out more widely. Places like China, Europe, apparently with better traffic behavior models.
So summing it up,
I'd say Tesla's FSD is really a radical departure. It's an AI-native approach. It's
Yeah.
betting on AI scale and that massive data flywheel to achieve autonomy, rather than building it up piece by piece with rules. It trades some interpretability for potentially much greater adaptability and scalability.
Which leaves us with a final thought to consider. What are the long-term implications for the whole autonomous driving field? An approach built fundamentally on AI learning and data scale versus one built on explicit engineering. What might that difference in architecture mean for how fast it can grow and maybe what the future of autonomy looks like? Something to think about. Thanks for joining this deep dive.